Hi everyone, welcome to Lecture 15 Part 2 on the combined methods. The objectives for this video are the following. After watching, everyone should be able to, number 1, describe the double method of agreement. Number 2, describe the joint method of agreement and difference. Number 3, apply the double method of agreement using property tables. And number 4, apply the joint method of agreement and difference using property tables. So there are 4 objectives for this lecture video, but we've already developed all the necessary skills to meet them quite easily, so we won't be going on forever with this one. So we're going to round off Mill's methods by looking at 2 combined methods, what they're used for, and applying those methods using property tables in the same way we've been doing over the last 3 videos. So here's where we're up to with things. The 2 combined methods we'll look at in this video are called, respectively, the double method of agreement and the joint method of agreement and difference. Now, the first method we looked at, the direct method of agreement, is used to find suspected necessary conditions. The second and third methods we looked at, the inverse method of agreement and the method of difference, are used to find suspected sufficient conditions, with the method of difference, of course, used to find suspected sufficient conditions with the additional property that those sufficient conditions are present in an occurrence of the given conditioned property. So the 2 combined methods we'll look at are used to find suspected necessary and sufficient conditions. The reason is that we combine the direct method of agreement and the inverse method of agreement in what we call the double method of agreement. So one method that finds necessary conditions and one method that finds sufficient conditions. And to obtain the second combined method, we combine the direct method of agreement with the method of difference. So again, it lets us find suspected necessary and sufficient conditions, but this time, because we use the method of difference, it will have the additional property that those sufficient conditions are present in an occurrence of the given conditioned property. So the double method of agreement and the joint method of agreement and difference down there in blue are what we'll look at in this video. Now, rather than kind of painstakingly go through examples that are very similar to what we've seen so far, I thought it would be better if we kind of discover how these combined methods work together, instead of me just telling you how they work. So the idea is very simple. You just combine each of the methods involved in each one, and you apply them both to the occurrences in a given property table. So let's start by looking at how to apply the double method of agreement. Remember, this is the combination of the direct method of agreement, which lets you find suspected necessary conditions, and the inverse method of agreement, which lets you find suspected sufficient conditions. So here are the 2 golden rules, just before I start asking questions. Golden rule 1, a property that is absent when a given conditioned property E is present cannot be a necessary condition for E. And golden rule 2, a property that is present when a given conditioned property E is absent cannot be a sufficient condition for E. So with that, here's a property table with some simple conditioning properties, A, B, C, and D, and some complex conditioning properties, not A, not B, not C, and not D. Your task is to find the suspected necessary and sufficient conditions for the given conditioned property E. We'll walk through it via a series of questions. So here is the first one. Pause and have a look at these occurrences recorded in the table. And then once you've had a look at them, you might want to copy them down, move the video on, and I'll ask you a question. So, occurrences 1 and 3 admit the direct method of agreement because there the conditioned property is present. So the inverse method of agreement won't tell you anything about those occurrences. Conversely, occurrences 2 and 4 admit the inverse method of agreement because there the conditioned property E is absent, and so there, the direct method isn't going to tell you anything. So we apply the direct method of agreement to occurrences 1 and 3 to find suspected necessary conditions for E. and we apply the inverse method of agreement to occurrences 2 and 4 to find suspected sufficient conditions for E. So here's the next question. Again, you might want to pause the video on this table before it jumps into the question so you can have a long enough look at it, because it will disappear when the question comes along. So you should have eliminated B, D, not A and not C in occurrence 1 because they are all absent while E is present. And you should have eliminated A, not B, not C and not D in occurrence 3 for the same reason. They are all absent while E is present. So the conclusion is, if one of the possible conditioning properties is a necessary condition for E, then C is that necessary condition. Here's the next question then. You might want to pause and have a look at occurrences 2 and 4 before you move the video on. Okay, so you should have eliminated A, B, D and not C in occurrence 2 because they are all present while E is absent. And you should have eliminated not A, not B, not C and not D in occurrence 4 for the same reason. They are all present while E is absent. So the conclusion is, if one of the possible conditioning properties is a sufficient condition for E, then C is that sufficient condition. So here is the last question. So we get to conclude this. If one of the possible conditioning properties is both a necessary and a sufficient condition for E, then C is that necessary and sufficient condition. And that is all there is to the double method of agreement. You simply apply each of the methods of agreement that we've studied, the direct and the inverse methods, to the right occurrences in the property table. So let's move on to look at the second of the combined methods we're looking at here, the joint method of agreement and difference. This method combines the direct method of agreement and the method of difference. Remember, the method of difference allows us to find suspected sufficient conditions that are present in an occurrence of the given conditioned property, which in this case will be E. And when we used the method of difference last time, we always started by looking at an occurrence 0, the occurrence of interest, in which the given conditioned property E was present. And then using occurrence 0, we defined the list of possible conditioning properties by looking at those which are also present in occurrence 0, because then they are the only ones that we'll be interested in. We apply the joint method of agreement and difference by starting exactly the same way. So here is a property table with 4 simple conditioning properties, A, B, C and D, and 2 complex conditioning properties, A wedge B and not D. There are 4 occurrences, occurrence 0, which is the one we'll use to define the conditioning properties of interest, and then 3 others, 1, 2 and 3. So the first step in applying the combined method is to define those conditioning properties of interest. So have a look at occurrence 0. Remember, 0 is always the occurrence we use to define the possible conditioning properties when we use the method of difference. So even though there is another occurrence down there where E is present, that is occurrence 3, we will only ever define the possible conditioning properties using occurrence 0. So pause the video and have a look at occurrence 0 and prepare yourselves for a question. Okay, you should have B, C and not D. They are all present in the occurrence of E that we're interested in, recorded in occurrence 0. So after applying this first stage of the method of difference, the next steps are simply to apply the direct method of agreement to find suspected necessary conditions, and to apply the inverse method of agreement to find suspected sufficient conditions. So pause and have a look at the table, copy it down if you haven't already, and there'll be a question when you move the video on. So you should have picked the occurrences in which E is present, because then the direct method of agreement can tell us about necessary conditions. They are occurrences 0 and 3. So pause the video again, have a look at the table, and there'll be a question coming up. So these ones should be the occurrences in which E is absent, because then the inverse method can tell us about sufficient conditions. So you should have occurrences 1 and 2. So have a look at the table again, and there'll be a question just after. So you should have eliminated A, D and A wedge B in occurrence 0, because they are all absent while E is present. And you should have eliminated C and D in occurrence 3 for the same reason. They are absent while E is present. So the conclusion is, if any of the possible conditioning properties are necessary conditions for E, then B or not D are those necessary conditions. Now notice that it might be any one of these or both. So pause again and have a look at the table and prepare for the next question. So you should have eliminated C and not D in occurrence 1 because they are present while E is absent. And you should have eliminated A and not D in occurrence 2 for the same reason. They are present while E is absent. So the conclusion is, if any of the possible conditioning properties are sufficient conditions for E, then B or D or A wedge B are those sufficient conditions. Now notice that it might be any one of these again, or any two, or all three. So we've applied all the steps we need. Since we're applying the joint method of agreement and difference, let's suppose we are interested in the strongest possible conclusion we can make. That is, we want to know which, if any, of the possible conditioning properties present in occurrence 0 of E are both necessary and sufficient conditions for E. So here is a question. Now, it's only B. Why? Well, the first step we applied to occurrence 0 says that we're interested in only the properties present in that occurrence 0 of E. So we're only interested in B, C, and not D. The rest are absent in the occurrence of interest, in occurrence 0. So then, using the direct method left us with B or not D as necessary conditions, both of which we're interested in, but using the inverse method left us with B, D, or A wedge B as sufficient conditions, and we're only interested in B out of that list. So B is the only conditioning property that is present in occurrence 0, the occurrence of E we're interested in, is a possible necessary condition for E, and is a possible sufficient condition for E. So, if any of the possible conditioning properties present in occurrence 0 are both necessary and sufficient conditions for E, then B is that necessary and sufficient condition. So, just before we finish, notice again that what we've concluded in the example we've just looked at is something of the form, if any of the possible conditioning properties are necessary and sufficient conditions for E that are also present in an occurrence of E, then such and such a property is that necessary and sufficient condition. Now, I've said this after all the examples we've seen over the last 3 videos too. The important thing is that for Mills methods, as we've been applying them to be useful to us, we have to be sure that our initial list of possible conditioning properties really does contain the kind of condition that we're looking for, be it sufficient, necessary, both, and so on. So how can we be sure of that? One basic suggestion might be to include all properties as possible conditioning properties, and then rely somehow on the uniformity of nature to guarantee that each conditioned property has some necessary and some sufficient conditions. But there are a lot of properties out there, so this is clearly impractical and it's not of much use to us. So perhaps a better suggestion is to ascertain what factors are likely to be relevant to the conditioned property that we're interested in. Perhaps there's a way of setting up a reasonable list of possible conditioning properties that are likely to contain the necessary or sufficient conditions that we're after. Now, the only way we can do this is if we apply some inductive logic to a previously acquired body of evidence. That is, Mills methods are only useful if we already have some inductive knowledge to help us set up our initial list of possible conditioning properties. And this process is not straightforward. The book talks about it a little bit, but we won't go into it in any more detail here. Instead, we'll suffice it to say that it is in conjunction with this kind of continual process of expanding our list of possible conditioning properties and then re-evaluating our results in the light of new occurrences that Mills methods are helpful in contributing to the growth of scientific knowledge. Okay, next time we'll look at how we might successfully apply the methods in quantitative fields as opposed to qualitative fields. So have a go at the last question, and I'll see you next time.